Hello, Triglets. All right, we're going to learn some more stuff about graphing today. Section 4.2. We're going to add in a couple fancy names for some of the things we've been doing, and we're going to add in a squash and stretch sideways. We've only had squash and stretch up and down. So one of the things I want you to be aware of is the general equation for trig functions. So y equals a sine, and then um, put a b here, and then x minus c, and then plus d. So we have 4 letters. We've only done 3 of them so far. We've done this one, which is a stretch, and we've done this one, which is a slide. This is actually, go back to A, stretch or a shrink. We've done a slide, and this is the opposite way, either left or right, and D is a slide up or down. So left for the left or right one is a plus, where it's a negative for the right. Plus is up, negative is down. Now B is going to stretch or shrink sideways. Oops, don't know how to spell sideways. This one is up or down. All right, actually I shouldn't write up or down. Let me back up to this. Stretch or shrink. I want to say, let me think here. Let's just switch this to horizontal. And this would be vertical up here. Okay. Now that I got things straight in my head. Okay, so that's a basic one. You have A, B, C, and D. Now we didn't talk about B because it complicates things a little bit more. We also need to give names to all of these. So A is called the amplitude. Amplitude. B is called the period. That's one wavelength. C, when it shifts left to right, is called the phase shift. And D is called the vertical shift. So we're going to be referring them to those 4 things now from now on. So not slides and shrinks, but amplitude and period and phase shift and vertical shift. All right, so let's check out B, what B does. So if I have y equals sine x, normal sine wave, 1, -1, pi, 2 pi. Normal sine wave looks like that. And then what happens if you have y equals sine 2x? What that 2 means right there is how many waves you can fit into that same space. We have a space of 2 pi. So this is how many waves fit into 2 pi length. So if that's a 2 there, that means I have to fit 2 waves in there. So I'm going to put little halfway marks. So 2 waves looks like that. Okay. So basically the wave, one wave now becomes half as long. So one wave is half the length. It only goes to pi now. Now they have a little formula to help keep it straight in case you forget if it's twice as many or half as many. The wave, one wave is called the period. It's how often it repeats. The period is found by taking 2 pi over b. 2 pi over b. So in our case, it would be 2 pi over 2, which is just pi. So that shows I'll do it in green. From here to here is a length of pi. That distance is pi from here to here. So one wave fits in a length of pi. So that becomes the new wavelength. Let's see what happens when I change it to a half. Y equals sine 1/2 x. Here's 1, -1, pi, 2 pi. Normal sine wave looks like so. This says that half a wave fits in 2 pi length. So only half a wave. So that means just the top half fits into 2 pi. So we're going to have to extend our graph. Here's 3 pi and 4 pi to finish the whole thing. So, and let's see if our little formula works. 2 pi over b would be 2 pi over 1/2. 2 divided by a half is 4. So 4 pi becomes your new wavelength. Okay, so this is really helpful. This really just tells you how far your wavelength is going to stretch out or shrink in between. All right, let's do a couple problems. And we'll add in the letter b in there. So let's say I have y equals 0.75 cosine 6x. Let's see what happens with that. You have to plan ahead a little bit. 0.75 is smaller than 1, so I'm going to make my 1's out a little bit. 6x, before I put in my labels for the pi's, I want to figure out what my wavelength is. So I'm going to do 2 pi over 6, which would be pi over 3. That's one wavelength has to squish into pi over 3. Now normally we put pi right about here and 2 pi out here. Whoops. But I don't want to do that. I want to label. We're going to change things up here a little bit. We're not going to do the original wave anymore. We're not going to draw the original cosine anymore, because we're going to run out of room on our paper if we have to stretch things way out. So instead of putting 2 pi out there, okay, this used to be 2 pi, we're going to change it to the wavelength of our new graph. So pi over 3 becomes where the old 2 pi used to be. And then this used to be pi. Well, now I'm going to cut this in half. Pi over 3 cut in half is pi over 6. So our graph isn't going to look a whole lot different. It's just going to have different labels. Now 0.75 is about here. Negative 0.75 is about here. So now I'm going to draw my wave in there. Since I already have everything labeled, I'm going to put little halfway marks for cosine. Start out at 0.75, bottom out at the halfway point, and come back up and end at pi over 3. So it doesn't look a lot different as if it were pi or 2 pi, but because the labels are different, we're able to draw it in there just fine. So this time, from now on, you do not have to draw the original sine and cosine graph. You want to figure out what your one wavelength is and put that in where you normally would have put 2 pi. All right, so now let's do one that has a couple more changes in it. So let's try y equals, let's say 2 sine, and then I have 1/2 x minus pi. Now this is a little bit different than our generic, this is our generic one. What's different is this 1/2 is on the inside of the parentheses and this b is on the outside. We have to get the 1/2 to the outside in order for it to be properly graphed. So 2 sine is okay. I'm going to bring the 1/2 outside. So it's like I'm going to take a 1/2 out front. Now the x is fine because 1/2 times x, 1/2 times x, but I have to figure out what this changes when I take a 1/2 out front. So basically 1/2 times what gives you pi? Well, 1/2 of 2 pi gives you pi. So that's a little bit tricky, a little triggy, but you just got to think to yourself, okay, if I distribute it back in, will I get the original that I had? All right, so now we can graph this. I know I'm going to have to go up 2 and down 2. I know I'm going to have to go to the right 2 pi, and then this, when the number's small, like a half, you're actually going to make a bigger graph. So I have to really watch out and have an extended graph that way. So I'm going to mark 2 and -2 because that's the amplitude. I'm going to figure out 2 pi over b is 2 pi over 1/2, which we said before was 4 pi. So 1, 2, 3, 4 pi. And then I know this means I'm going to have to go to the right 2 pi more. So there's 5, there's 6 pi. So I've set up my grid here to accommodate all the changes that I've had. All right, so let's draw the sine wave. I am going to do the sine wave. I'm not going to do this part yet. I'm not going to do C. I'm going to do A and B together, and then I'm going to do C. It's too much to do it all at once. So A and B together, I know I have to end at 4 pi. It's the sine wave, so it's going to look like that. Looks like a normal everyday sine wave, it's just the labels are different. So now I have to move everything to the right 2 pi. So instead of starting at 0, I'm going to start at 2 pi and have the same exact wave. Okay, or you can think of moving each of these over, each of those crucial points over to the right 2, and then redraw it again. All right, so you have to get the b out front, and that when you bring that out front, it's going to change that second number in the parentheses. You have to remember to distribute it back in. You need to be able to get this original expression back. All right, so A, B, C, and D, make sure you do them in order. You can do A and B together, and then do C and then D. Do those separately. And you do not have to draw the original sine or cosine anymore. And 2 pi over b is really the only formula that we need to know so far. All right, that is it. Don't forget, if you love Trig, Trig will love you right back.